started recording, but it's not live.
Okay. If you hadn't seen them, we've got donuts over there. Let's see, how many people do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, just grab like one for now. All right, hello, my name, for those of you who don't know, is Jonathan De Koning. Not that it matters, but today we're going to be talking about prefix sums, which are sort of a problem-solving technique that is not really, hopefully, hard to understand, but maybe you haven't been taught this. I'm not sure. We'll see. Quick show of hands. Does anybody, have they heard of prefix sums before, used them, heard of them? Any sort of experience with this? Yes, yes, yes. All right, that's about what I expected, a few people. Okay, let's take a look at this problem, which is kind of the essential prefix sum problem, kind of the most basic reason we would use it. And then the other sort of problems we'll look at are ways you can use prefix sums. But this kind of distills the essence of the problem into one question. So we're given an array of integers, of n integers, so some arbitrary size, and we have some number of queries, k queries. And each query, we're given a range from A to B, or left to right, and we need to figure out what the sum of the values are from that left index to the right index. So as an example, if we're given as input, say 8 and 4, which 8 and 4 is n and q, so the number of values in the array, 8 here, and then the number of queries we're going to get, 4, 1, 2, 3, 4 queries. Then we're given the array of values of size n, so 8. And that's 3, 2, 4, 5, 1, 1, 5, 3. Hopefully everyone can see that clearly. And then we're given some number of queries. So this first query is 2 and 4. So we want to find the sum of the values in the array from index 2 to index 4. Let's see, they are one indexing here. So that's going to be 2, 3, 4, which is 9 plus 2, so 11. And indeed, that is the result of that first query. And that is essentially the problem that prefix sums are trying to solve, is doing this efficiently. So the naive solution for a problem like this should hopefully be pretty obvious. Does anybody have an idea how we could solve this doing nothing smart at all? Yes? Yeah, exactly. You have some for loop, and for each query, you get your left index and your right index, and then you just loop through from left to right, adding it up as you go along, and then you print the output, and that works, right? We can say, have some for loop for these three. 2 plus 4 is 6, 6 plus 5 is 11, and then you go along the queries doing things like that. And the time complexity for that is, hopefully O of n, right? It's a linear operation. So the time complexity of this entire thing, if we were to do it naively, would be O of n times q, right? However many queries we have, well, we're going to multiply that by the time for each operation, which is a linear time sort of deal, because in our worst case, it would be from 1 to n our query every single time. But that's not going to work for this problem, right? And the reason it's not going to work is take a look at our input size here. N and Q can both be up to 200,000. So we could potentially have an array that's 200,000 numbers long, and we also have 200,000 queries. And so if we're iterating over a 200,000 size array 200,000 times, well, our time limit for this problem is 1 second, 200,000 squared. That's 40 billion operations, and that's not going to cut it. It's not even going to be close, right? So we have to do this in a more efficient manner. And that's where prefix sums come in. Prefix sums allow you to do a tiny bit of pre-processing. And then after you've done this pre-processing, you can answer these queries, these subarray sum queries, in constant time. So basically instantly, like one operation, essentially. Assuming that you don't ever update what the array looks like, right? So you can't like get the sum from 2 to 4, and then, oh, I want to change what the number is at index 3, like that. You're not going to be able to do that. You're going to need some different data structure called the segment tree or something if you want to do that. But that's beyond this. OK. So how do we do this? Well, it is, thankfully, pretty simple. Let's see. What is this? 3, 2, 4, 5, 1, 1, 5, 3. Three, 2, 4, 5, 1, 1. What was it? Second to last? 5? 5, 3? Yeah. OK. If this is our array, let's just section this up. And oh, that's an ugly cell there. OK. What a prefix sum array is, or I guess before that, what we need to do is create a prefix sum array. And this is very simple. All a prefix sum array is you keep a running total of the sum of the array, and at each index, you have some new array, and for each index, what you put in the index of your new array is just the running total of the numbers that you've seen so far in the previous array. So what that might look like, or what it will look like, is as follows. OK. At index 0, or 1 if we're 1 indexing, the running total of everything we've seen so far is 3. And then here we add 2, so it's 5. Here we add 4, so 9. We add 5, 14, add 1, 15, add 1, 16, so on and so forth. This is a prefix sum array. What this allows us to do is as follows. If we want to find the sum of some subarray, let's say this one right here. 2 plus 4 is 6. 6 plus 5 is 11. What we need to do is we get the same indices with the left point shifted down 1, and we subtract the big value, or we subtract the small value from the big value, right? So we essentially say if this is A, and this is P, we say the sum from, say, L to R, oops, of A, or I did this poorly. Oh, Lord. Sum of A from L to R is equal to P at R minus P at L minus 1. And we'll run into an issue if we set it up exactly like this, but it should be good for now. Yeah, okay. Given some L and R, assuming you don't find the edge case here, the sum from L to R can be calculated by getting P at R minus P at L minus 1. So for example, this 2, if we wanted to find the sum of A from index 1 to index 1, so just like the first one, well, that's going to be P at R, 5, minus P at L minus 1, 3. So 5 minus 3 is 2. And there you go. And that works for anything except for the little edge case where you have L being the very first element here, right? So if L is 0, then you're going to end up looking for P at L minus 1, and then you're going to get an out of bounds exception, which is why we usually shift this up a little bit, and instead we move all of this to the right by 1 and put a 0 here. And then this now becomes P at, I believe, R plus 1 minus P at L. So then, back to our previous example, we've got, let's see, this is 1, 2, 3, 0, 1, 2, 3. So that's going to be P at 4 minus P at 1, 0, 1, 2, 3, 4, 14, minus 0, 1, 3 is 11, 14 minus 3, 11, and then 2 plus 4 plus 5 is also 11, and there we go. And this avoids the out of bounds problem because this R here, like if we look at both extreme cases, if R is at the very end, that's going to be fine because P is 1 bigger than R, or sorry, is 1 bigger than the length of A. So we're fine there. We just grab the end one, and then we never go past or behind L. So even if L is as small as possible, 0, then we're not doing L minus 1 anymore. Okay, so given this, let's solve this first problem. And what I'm going to do is just kind of solve this in Python. And then we're going to take a look at some other problems, and you will try to solve those. So let's do that. Let's open some crazy. Don't look too hard at my folders. All right. So, okay, first line we've got N and Q, and then our array, and then the queries. So we can say N and Q. N and Q, we grab those integers. I just have a little snippet here that will just get the input and split it up and then convert everything to integers. So we get N and Q, and then we get our array, which I'll call A. And then what we want to do is compute the prefix array. We'll call that P. And we'll start that with a 0. And we can say for num in A, we'll have some counter. Count is equal to 0. Count plus equals whatever the number is. And then append that to the end of P. And then we'll just pause here and print P and make sure that we're getting what we want. I've got a little helpful extension here that will run some test cases. It's saying we're giving the wrong answer, which is true because we're just doing some debug stuff here. But this is what we're printing out as the prefix array. So we're getting that 324, 51153. And then for our prefix array, everything seems to look good. We've got 0 as our first one, and then 3, and then 3 plus 2 is 5, and then so on and so forth, right? Everything looked good so far. I hope. Sorry, I haven't paused for questions. Does anybody have any questions?
How did you get that extension?
Yeah, so the extension is, I believe, called CPH Judge. So if you're using VS Code, you can just search for CPH Judge, and it should be there. However, I also have a website extension called, what is it called? Competitive Companion. If you install that and set it up, that'll just make it so that you can click this button here and all the test cases will be sent to here. Otherwise, you'll have to copy and paste them in manually. Okay. Any other questions? Cool. So then we need to grab our queries. So how many queries do we have? Well, we have Q queries, so we can say for blank in range Q, L and R for left and right. We grab those. And then all we want to do is print P at R plus 1 minus P at L. And if we run, what have I messed up here? Oh, I did the old one. P at R, or wait, did I mess it up? P at, I know why. It's because we're one indexing. The problem uses one indexes, and I prefer 0 for hopefully obvious reasons. So just before we do all this, we'll subtract 1 from both L and R. And we've passed all the test cases. We can take a look at this. So our expected output is 11 to 24, 4, and we are getting back the same output. Okay. So if we submit this, this should hopefully pass. This specific website can be kind of stingy with the time limit for Python. So sometimes even if you've got like a perfectly good Python solution, you need to like optimize it even more by doing some crazy whatever, I don't know. So this website I usually do in C++, but hopefully we should be good. Okay. And that was accepted as well. We've got this crazy test case over here, and this all works. One thing that you should be careful of, is anybody using C, C++, or Java? Yes? Yes? One thing you need to be careful of is you cannot typically use ints for this because you're going to run into an integer overflow because you, like for this problem, we have potentially 200,000 numbers, and each of those numbers could potentially be up to 1 billion, and so you're going to overflow very fast. So typically, for prefix sum stuff, you'll need to use like long longs. For C++, I forget if they're called the same thing in Java, but sort of the biggest number thing you can find. Does Java have big integers built in?
It does.
It does? Okay. Like automatically, or do you have to call big integer?
So you can declare a variable as int, but if the number is too big, you have to declare it as something else.
Yeah. Okay. Does it have like arbitrarily sized integers like Python?
We're not with arbitrary, sorry.
No worries. Like in Python, if your number, like the only limit to the size of an integer is like how much memory you have on your computer. So it'll just automatically allocate more memory for a number as it gets bigger and bigger. So it could be like ginormous. That's called a big int. Big int Java. Okay, looks like it. But long should be sufficient. If you're using Java, you can figure it out. C++ though is long. Okay. All right. Any questions at this point? Yes.
Could you maybe like visualize your like input or like a test case for your code?
Sure. So let's take a look at this test case here, 1.8, and we will go into the Excalidraw because this is the same input. Let's see, this doesn't really match up very well. Can I make like no. All right. So let's assume this is 0 indexed. 0, 1, 2, 3, 4, 5, 6. I apologize for my handwriting. Okay, and as input, we are given 1, 8. So we need to find the sum of the numbers in A from index 1 to index 8, except it's given to us as one index, which is kind of weird. So the very first thing we're going to do is convert this into 0 indexing by just subtracting 1 from both. As it so happens, this is asking for the sum of the entire array. So maybe this isn't a great example. Let's change this to, maybe this was 2, 6. And so now it's going to be 1, 5. Okay, 1, 5. So 1, 5 is this subarray right here, 1 to 5, inclusive. So the answer we're looking for is, going backwards, 1 plus 1 is 2, 2 plus 5 is 7, 7 plus 4 is 11, 11 plus 2 is 13. Hopefully, I did all that right. Oh wait, did I not? Yeah. Okay, so we're looking for 13, sum from 1 to 5. And so what we have done is pre-computed the sum of every prefix, right? Starting with like the null prefix. So we know the sum of all the numbers up to here. We know the sum of all the numbers up to here. We know the sum of all the numbers up to here, and so on. So to get some arbitrary section, right? If we have all the prefixes, to get an arbitrary section, like here, all we need to do is get the sum of the prefix up to this point, and then subtract off whatever we don't want to the left of that, right? So if we want, it's kind of like the principle of inclusion and exclusion. If you all are familiar with that. So like imagine this is, let's say, imagine this is a bunch of 2s. Two, 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 two. And then here we've got zero, 2, 4, 6, 8, 10, 12, 14. So if we want some arbitrary section, well, we have all the prefixes, right? Assuming you guys know what a prefix is. Prefix of the array, just the sum up to some point. So to find the prefix of some arbitrary section, we first get the sum of the prefix up to the right index. So that gives us all the sum of this. But then to get just the sum of this blue bit, we have to subtract all of this. And since we've computed all the prefixes, and we can do that in linear time, this is very simple. So to get the blue, to get the sum of the blue, we get the sum of the green and subtract the sum of the red. And both this green and the red are prefixes, which we've already calculated. So to get the sum of this blue, we get the sum of the green, which is this r plus 1. So r here is 5. So we get the green like this. Green. This green bit. Although the green actually should probably be like here. Get this green, which is all just in this number here, right? This is the green. So that's 5 plus 4, 9, 9 plus 5, 14, 15, 16. That's what this is. This at index 6 is just the prefix sum of everything up to index 5. But then what we need to do to get this sum of the blue is subtract off everything to the left of it, which is just this 3, which is this bit here. And so our total computation ends up being the prefix of the right plus 1. We're doing the plus 1 because we need that 0 at the beginning, minus the prefix sum of the left index. So we've got 16 minus 3, which is 13, which is our answer. Is that more helpful? Okay. Any questions? Yes. Yeah, code again. Okay. Yeah. Yeah, because we do the 0 at the beginning for the edge cases when L is equal to 0. So we start with a 0, and then we have our counter, and we go through the whole original array, increment the counter by whatever that number is, and then add it to our prefix array. And then for each of our queries, we get the L and R, subtract 1 from both to convert it to 0 indexing, and then we just get the whole prefix sum of everything up to the right index, but we do the +1 because of our 0 there, and then all we need to do is subtract off the prefix sum of everything up to the left index.
Yeah, because you already had the 0 there, like for mine, I just left it as L, like the L and R without subtracting the 1, and then just like the normal, like R minus PL minus 1. Just because the 0 most fixed the indexing for you.
Yeah, you do need to make sure you've got your indexing correct. You can do either one, but hopefully you can understand kind of the concept that you're shooting for, and so when a mistake arises, you can know kind of what you're doing wrong. Sure. Like in the real world? Let me see what a good example would be. So there's not a bunch of like easy analogies, I guess, but oftentimes when you're in software and you need to query something, if you're doing a bunch of queries, there's usually some pre-processing you can do to speed up each of those queries. And the pre-processing can be cheap, just like what we're doing here. I don't know if I can just grab a random, like contrive some example. Well, I won't tell you exactly how it works, since that's kind of for you. But here are some sort of examples of problems that you can use it on. So if we're given some string S and Q queries, we need to print how many characters A are in that string from L to R. We've got this one here, which is a bit more complicated, maybe this one. We've got a strip of checkered paper. Each cell is either white or black. And we need to figure out the minimum number of cells that have to be colored from white to black in order to have k consecutive black cells. Crazy. And then if k consecutive black cells already exist, print 0. You could, I mean, I'm kind of not completely anti, but kind of anti-AI. But for some kind of like arbitrary analogy like that, I can't really think of one, but I'm sure ChatGPT could figure out like a good real world use. It's just I didn't have anything like that prepared. But yeah, okay. So as we just saw like 5 seconds ago, this is the first problem for y'all. If you don't have a Codeforces account, it's super easy to set up, and I think you'll need to submit code to this problem. But I mean, you could also run these test cases yourself. If you get these correct, you're probably right. But if you want to submit the code, I've put the link to these problems in under problem sets, I think. Problem sets. So these are the 3 problems for y'all. And if you're feeling a bit spicy, you can do the challenge problem if all this is beneath you. And if the challenge problem is too easy, then see me after class, and I got more for you to do. OK. So this is the first problem for you guys to solve. Given a string S, we're given Q queries. This is kind of familiar. Before we had an array, now we have a string, which is kind of similar, especially if you're coming from C. We need to answer Q queries. We've seen that. And we need to print the number of A's, as in the character A, how many there are, from index L to index R. And that's it. That's like a super short problem statement. It's very easy to understand. L and R are one indexed again, so I would convert it, but you can. I mean, I just think that's easiest. Yeah, so solve away. I'm gonna get a donut.